Part 3 of this video was starting to get a little bit long, so I thought I'd split it into two parts. While the last part was called the Return of ANOVA, I guess you could call this part the Mandalorian, as some sort of in-between between what this video series would do and what some future series that may not ever get shot will do. So, I wanted to show you how to run ANOVA on the toy example data. I wanted to show you how to do that first by actually computing out all those statistics explicitly so you can kind of get a little bit of feel for what those numbers are. And then second, I wanted to show you how to do that using R's built-in ANOVA function so that you can get practice in reading what are standardly called ANOVA tables. Now, to break down this code, I would also recommend that you familiarize yourself with the dplyr package. It's a very useful package whenever you want to summarize things in R. So I put a link to this package in this supplementary document, link to a help file for that data. So take a look at that and I'll kind of explain how I'm using this code. Now, going through these lines, the first line here is just defining our toy data set. We have 3 groups and there was 3 samples per group. So that first rep 1 through 3 is just creating those group numbers, and the YIJs then are those observed values. The Y bar in our videos was the Y bar double dot the overall mean. And then I'm using the dplyr package here. I'm taking the toy data set, I'm sending it through what's called a pipe operator, and I'm commanding dplyr to group that data by the variable group. So that's going to basically take toy and partition it up into group 1, group 2, and group 3. And then anything I pipe through after that with the summarize operator is just going to compute statistics within each group. So first NJ, the length of Yij, that's basically going to compute how many observations in each group there are, which is going to be 3. Y bar J is just going to compute the within group means. And then the SSJ, this is basically going to compute the contribution of each group to the sum of squared errors. So I'm just adding the sum of squared differences between the observations in the group and their individual group mean. So moving down to the next line, let me erase some of these so you can see better. The SSE then just adds together all those observations. The SST, which I'm actually not going to use in this calculation, but put it in here for some reason anyways, is just the overall sum of squared differences between the observations and the overall mean. And then the sum of squared treatment here is what I'm doing is I'm looking at the group sizes and multiplying them by the differences between the group means and the overall means squared, right, and adding those together. Now, the degrees of freedom 1, that will be the degrees of freedom of the numerator. That's just k minus 1. So there's 3 groups, so hence 3 minus 1. Degrees of freedom 2, remember, is n minus k. So that's the sample size 9 minus number of groups. And then this F observed is our test statistic we're going to use, the MSTR over the MSE. And the last line then just computes the critical value from the appropriate F distribution here and compares it with our observed. And in this case, we can see our F was certainly greater than the critical, right? Which means that we're in that upper tail of the distribution, which means that the variability between groups, which was our numerator, is much larger than the variability within groups, and that means that we can reject our null hypothesis and conclude that there's evidence of a significant difference between the group means in this experiment. So R has a nifty function, AOV, which allows you to summarize this information a little bit more compactly. In fact, everything that we did in those last few lines can now just be done by a single line of code. To explain this, the format here is you're using your Y variable on this one. Let me get some ink going on here again. So this right here, think of this as your response. And this is your grouping variable or your independent variable here. So what we're saying is we want, remember our ANOVA model is that essentially Yij equals mu j plus epsilon ij. So this sort of tilde notation here is kind of a simplified way of saying this, that we're treating Yij as a function of group and we're feeding it the data set toy that contains these observations. So summary of AOV will give you the table that's displayed in this output here. And this is what we call an ANOVA table, analysis of variance table. Now notice that the F value, let's start from this side and work our way back. Okay, this one right here is the p-value for the test. And it's the probability that we would see an observation that's greater than or equal to our F value. So just like when we did this by hand, in that case, our F was bigger than the critical value. In this case, if we're doing a p-value test, we would say that our p-value is less than the standard 0.05 significance level. And so again, the conclusion there would be to reject. Now, if we look to the left, we see the other quantities which were used in the computation of F. So F itself is a ratio of these two mean squared quantities. The top one, where it lists group here, think of that as the sum of the treatment values, the variability between groups. And the second one, where it says residuals, think of that as the E's, the errors, right? So in our F statistic that we had up here, right, the numerator, the SSTR over DF1, let's see if I can switch colors here. Okay, that corresponds to the 7 down here. And the denominator corresponds to this 1. If I go to the line left of that, you can see that both of these mean squared errors were actually computed as the 14 divided by the 2 and the 6 divided by the 6. Okay. Maybe those lines are a little bit backwards, but I think you get the point. So the 14 would be the SSTR, the 6 would be the SSE, and then the 2 and the 6 would be the DF1 and the DF2, respectively. Right. Now, we can also see this, just to give you one more example to practice reading these. I also wanted to do this for our mosquito data set, where we had the following, and I put the box plot on its side for it was just how I was feeling today. There was no specific reason, but this is similar to the plot that occurred on part 1 of the part 1 video. And you can see here that there are certainly some locations, in particular this KNWR location, which seems like they had a much higher median log values than the others. Now, I've put this on the log scale because one of the assumptions of ANOVA, by the way, which you saw in the other videos, right? One of the assumptions of ANOVA is that the values are normally distributed. So they're either this or this, right? Either way, they're normally distributed. So you can see here that looking at this box plots, even on a log scale, there's some outliers on these ends, and there's a little bit of skewness in some of these. For example, this one has a little bit of a left skew to it, but overall, they look much more normal than if you plotted them on a non-log scale. So this is a common technique of log transforming your data before performing ANOVA. So moving down to the actual ANOVA output, we can see in this case, the degrees of freedom was 8. Now that was basically the number of groups minus 1, and the errors degrees of freedom was 490. That's because there was 499 observations in all, right? So that's minus the number of groups, the 9 groups, which gave us 490. These sum of squared quantities, right? Those would end up being, if we were looking at that, the top one here would be the SSTR in our notation. This one would be the SSE. Then dividing the sum of squares by the degrees of freedom gives us the mean squares, and taking their ratio gives us the F value. And we can see in this case our p-value is incredibly low. There is highly significant, it looks like that there is a highly significant difference in expression levels between these different sites. So we hope that this has given you some ideas about ANOVA. I'll be uploading this code in a supplement, and there'll be 2 quizzes on these videos. And this will probably be the last video series for this semester, other than perhaps some review videos, which we might post depending on student needs. But we hope they've been helpful to you. I have to admit I've somewhat enjoyed making them, even though sometimes I didn't want to make them. And please let me know if you have any additional questions.